Okay, so now looking at question 2, right? We are given a quadratic sequence, and we are asked to find the nth term, Tn, of the sequence. So we are asked to find the equation of the quadratic sequence, right? So the first thing you're going to do is you're going to find the difference of these, right? Which we call the first difference. So you find the first difference. The first one is 28 and 20 and 12, right? So that's going to be your first difference of the sequence. Then your second difference of the sequence, you will get -8 both. So now you'll be having your first difference of 28, 20 and 12, right? Your second difference would be -8, right? Which is constant. So which means you're going to say 2a is equals to -8. Then your a value is going to be -4, right? And then 3a plus b will be equals to the first term of your first difference, which is 28, right? And you know your value of a, you're gonna substitute it, and your b value should give you 40, right? And then your a plus b plus c should be equals to the first term of the sequence. So a plus b plus c equals to the first term of the sequence is our 72. So it's 72. Then your c value should give you 36 degrees once you substitute your b and your a, which you found previously. Fine. So now you have your a, your b, your c, and you know very well that your general term is Tn is equals to an squared plus bn plus c, right? And your a value is -4, so it's -4n squared, and your b is 40 plus 40n, and then plus 36. So that is the equation, the nth term of the quadratic sequence, right? Fine. So now the second question asks us to do this. It says that determine in the quadratic sequence, which is the sequence that we were given, is equal to the 12th term of the sequence of the first difference, right? So it's very important for us to really read through 2.1.2. So 2.1.2, now that you are done with this one, 2.1.2 says that a term in the quadratic sequence, a term in this sequence, right? A term in the quadratic sequence that we are given is equal to 12th term. A term in this sequence is equal to 12th term of the first difference. So the first difference of your quadratic is an arithmetic sequence. Alright, so you don't need to memorize that it's an arithmetic sequence. Just like when you derive a quadratic, you get a straight line. You see, so it's an arithmetic sequence, and then determine the position of this term in the quadratic. So they are telling you that the 12th term of the sequence of the first difference, it term in this quadratic sequence is equal to the 12th term of the first difference. So which means we have to write the first difference first for us to solve this problem. So the first difference is 28, 20 and 12, and we know that the difference here is -8, so -8, so it's constant. So we need to find our equation of the arithmetic sequence. Tn is equals to a plus into n minus 1 d, and you substitute your a value, which is 28, you substitute your d value, which is -8. Your Tn should be equals to -8n plus 36. So -8n plus 36. So this should be your Tn your equation of your first difference of the sequence. Then they're telling you that that sequence, or that equation rather, is equals to T12, the 12th term. So meaning T12, it's equals to T12, right? Of minus 8n plus 36. So which means where there's n, you're gonna put 12. So 12 there plus 36, right? So you're gonna get minus 60, right? So now you found the T12 of the first difference. Then the question says that determine the position of this term of the T12 in the quadratic. So we want to identify its position in the quadratic sequence, meaning this minus 60, it's going to be equal to the quadratic. So the quadratic equation, which is an squared plus bn plus c, which we found to be equals to minus 4n squared plus 40n plus 36. So the Tn will be equals to the minus 60. So you're going to write minus 60 is equals to minus 4n squared plus 40n plus 36. Then you're going to solve your equation, then solve for n, right? So you're going to solve for n, and you should find n is equals to 12, or n is equals to 2 minus 2, right? Of which your number of term can't be negative, so this goes away. So your n should be equals to 12, right? Once you've solved in this equation here, right? So fine, that is going to be your 2.1.2. N is equals to 12. Good. Now in 2.1.3, you are asked to find the maximum value of the quadratic sequence. So remembering that a maximum, when they talk of a maximum of a quadratic sequence, which basically means a quadratic equation or graph, then if you draw a quadratic or a parabola rather, this is the point of maximum of a parabola. It's at the turning point. If they say identify the maximum of this graph, you're going to look at the y value of the turning point. There's x and there's y. You look at the y value to find the maximum point of the graph. So in this case, to determine the maximum value of the quadratic sequence, we need to use the equation of a quadratic sequence, minus 4n squared plus 40n plus 36, and then we find the turning points, which is use this formula, x equals to minus b over 2a, and then you substitute the answer you're going to find here inside this original equation. So your turning points, you'll definitely find them using this equation, and it will be 5 and 136. These are going to be your turning points. So the maximum value, looking at this 5 and 136, it's the y value which is equals to 136. So that is your point of maximum of the graph. Now going to 2.1.4, it says that determine the value of the maximum value of the sequence. So now we are given this sequence, and if you take a look at this sequence and this one here, when you find the difference between these, it will give you the same first difference that we found previously of 28, 20 and 12, right? But now, and it will also give you the same constant difference, which is minus 8, right? So now we need to look at what's different between these two sequences. It's actually the first part of the sequence. It's this part that is different. And if you can find the difference between these two, so which means if you find the difference between the if you find the difference between the first term of this sequence and the first term of this sequence, you're going to get 95. So what I'm saying is 72 minus 23, you should get 95 actually. 95. And even here it's 5, and if you subtract in 100, you're going to get 95. So the difference between these two sequences is actually 95, right? So to find the maximum, the point of maximum that they're looking for here, what you do is, you know very well that you have 95, which is basically the difference between the original sequence and this one. And then you know the maximum value of the quadratic sequence, it's equals to 136. So you want to say maximum value is equals to 136 minus 95. Then you get your answer here of 41. So this is going to be the maximum value of 2.1.4. Now, looking at 2.2, we are given this sequence and we are told that this sequence follows an arithmetic sequence. So basically the differences of these sequences are going to be equal, right? So if you find the difference between these, you should be getting 2 sine of 3x minus minus 11 equals to 15 minus 2 sine of 3x, right? So the difference between these terms here, t2 minus t1 equals to t3 minus t2. So that is how it is going to be in this problem. Then you solve for x. So you will solve by collecting the like terms, meaning this will go to the other direction with this one. So now I have 4 sine of 3x, and then if you solve these two guys here, you should be getting minus 4 equals to 0, and then your x value should be 30 degrees once you have solved this small portion here, right? Which will transpose the 4 to the other side, divide by 4 because they're similar, and then you will find the arc of sine 3x, then you divide by 3, you get x being equals to 30 degrees. So that is the answer for 2.2.